Awesome. Hi everyone, how are you guys doing? I am super excited to see a good number of attendees today, and we were especially very excited and almost overwhelmed at the number of attendees we had the last time. We were super excited that we have so many people interested in drones, so many innovators, so many future engineers who are going to not only build drones and fly them, but create some awesome drone innovations that will propel India as the drone capital of the world in the next 10-20 years. I'm very excited to have you guys, and I'm very happy that I get to be a part of your drone journey. So quickly, I hope you guys had a lot of fun last time. And last time was actually just the sort of warm up of the entire course, like the entire series that we're going to have. A lot of fun bits start today, and that's what we're going to talk about. A quick note: we have uploaded the video of the last time's session on YouTube. So for those who might have missed out on the last session, feel free to check out our YouTube Drone Aviation channel. You'll find it there. You'll also find quite a few fun videos there. So feel free to check those out. But yes, in fact, I believe you might be getting an email with the link of the last session's video. At the same time, you can just reach out to the Drone Aviation YouTube channel and check out last session's video. One more very exciting, interesting thing was the last time we had almost 2,000 questions that came our way. 1,000 of them were sort of poorly framed, like we couldn't understand them. 1,000 of them were kind of valid questions, and we published quite a few of them. Now, it is actually, since we have a small team, it is actually very difficult for us to go ahead and answer each of the question. So let me put up a small request. Before you put out a question in the Q&A section, just check out the list of published questions and answers. I believe a good number of your questions will be answered there. And at the same time, the questions which are not repetitive, which are new, we will definitely answer them in the section, and we will publish them for everyone, right? With that, I am going to hand over the mic to our master trainer, Keval Ajmeri. And why don't I, give him bring him on the dais and take this forward. Keval, sir.
Hello, hi everyone, and welcome to the second session of the drone webinar. I suppose you all can see the screen right now, and you can see what we are going to learn today. So basically, we are going to cover a very important part of any flying system, that is stability and control. Now, I am aware that a lot of you might have missed out the previous session, and you don't need to worry. In every session, we will be having a little bit of revision from the previous one so that you guys remember everything properly for whatever is required for the particular session. And in any case, you can obviously check out our YouTube channel, and we are going to post all the sessions over there, and you can go back to them again and again if you want and learn, keep on revising the concepts. So coming to today's session, we are going to learn about stability and control. So I guess we can simply start with the webinar, and we'll understand what this is. So firstly, let us know what is the agenda for today. First thing is revision of concepts. Then we are going to study is about equilibrium, stability, and then control. Very simple. Now let us first revise a few of the concepts that we learned previously. You might be remembering this: forces of flight. So in any flying system, there are many forces that act on it, but we learned about four basic forces, four most important forces, and these are thrust, lift, drag, and gravity. So if you remember, lift is the force that allows a system to go up in the air. Gravity is the weight of the system that will act downwards and bring the system downwards. Thrust is the force that propels the system in the forward direction in whatever direction you want to go, and drag is like the resistance. So when a system is moving forward, the air will put resistance to it, and that force is called as drag. So we have these four basic forces on any flying system. Then we learned about the principal axis. In any flying system, we have these three axes. The first one is the longitudinal or the roll axis that runs from the back of the drone to the front of the drone. So this is the roll axis, and this motion is called as roll. Then we have the lateral axis that goes from the left to right of the drone. So left to right of the drone like this, and this motion is called as pitch. And then we have the yaw axis that goes from top to bottom of the drone, and this motion would be yaw motion. Okay. So coming to the motion. Before this, I would like to show you a basic nomenclature for our drone. So if you can see the drone right now, this is the front, and this is the rear of the drone, the back of the drone. So I would like you to remember this, because a lot of times I'm going to show these motions, so it will be easier for you to understand with respect to what is the front and what is the rear of the drone. So this is the front of the drone, and this is the rear of the drone. Okay. So the roll motion was the first that we learned. So roll motion is the left-right motion of the drone. The next one was pitch motion, which is the front-back motion of the drone. And the third one was yaw motion, which was the 360-degree motion of the drone. So I guess this brings us to the current topic, the topic for today. The first thing that we are going to learn is equilibrium. Now, you might have learned all this in school, in physics and science. Some of you will learn ahead, or some of you might have learned. It is a very easy topic and a very interesting one. So let us quickly understand what this is. So you might be aware that on any body, a lot of different forces are acting. For example, if you see on the screen, we have a box, and if you try to push the box, there are basically four forces that we can see right now. The first one is applied force, the force that you apply to push the body. The opposition to this is the friction, as we all know. Then there is the weight of the body that acts downwards, the gravity that you see on the screen, and the surface on which the body is resting will apply normal force to the body. So the important thing over here is not that there are these many forces. The important thing is there are different forces that act on any body. So it might be your computer on the table, it might be anything. There are different forces that act on a body. So this is the first thing that we learned. Now, what is equilibrium? Equilibrium is a state where all these forces cancel out each other. Cancel out, or the resultant of all these forces is equal to zero. Now what does this mean? If you see on the screen right now, the box that you see, there are four forces we have shown on the screen on the box. Now the length of the line is more or less the same, right? So because of the length of the line is same, it indicates that the quantity or the amount of force that is applied is also equal. So the number of forces may be 4, maybe 10, maybe 400, but if all of them are equal to 0, if they are going to cancel out each other, this is called as a state of equilibrium. Consider a tiffin box that you share with your friend, and if you have brought something very interesting, and two of you are fighting for the tiffin box. So if you are trying to pull it, and if your friend also is trying to pull it, and if both of you are applying equal amount of force, the tiffin box is not going to go anywhere. It will stay at that position only, and that tiffin box will be in a state of equilibrium because the forces are cancelling out. What would happen if someone is applying more force? the tiffin box will move towards that position. So I guess this would make it clear about what equilibrium is. The next thing we understand is stability. What is stability? What do you mean by stability? The first type of system that I want to tell you about is stable systems. So if you see on the screen, the green part can be considered as a bowl, okay, and this red ball is kept inside it. Now, what will happen if I don't do anything to this system and I just let it be as it is? If you are able to guess, the ball will obviously not move and the ball will stay over there. Why? Because of equilibrium. All the forces are balanced and there is no external force acting on it. So the ball is going to remain over there. Now, what will happen if I push the ball a little bit? Not by a very big force, but I push the ball by a little bit of force. I think you will be able to guess. So if I push the ball from this direction, from the left direction, the ball will go in the opposite direction. But is the ball going to stay over there? I don't think so, right? The ball, what will happen is the ball is going to return back at the bottom, but it is obviously not going to stay over there also, because when the ball is falling, I think it is very easy to imagine the ball is going to go to the other edge of the bowl. So the ball will keep on oscillating for a little bit of time till it comes back to its original position that you can see right now. So when I will be disturbing the system, when I will be applying some force, I am going to disturb it. So when I am going to disturb a system, the system will oscillate. Okay, the system will oscillate, but after a period of time, it will come back to its original position. This is called as a stable system. So the definition or the basic idea behind the stable system is that whenever a system is disturbed, but it comes back to its original position, that is called as a stable system. This makes it easier to understand the unstable system. It is very intuitive from the screen itself. If I don't disturb the ball, it will remain over there. But if I am going to push the ball a little bit, what will happen is the ball will fall on the other edge of the inverted bowl, or a mountain as some people call this. So the ball is going to fall from the other side. But in this system, do you think that the ball will magically come back to its original position? I don't think so, right? So in this system, what happens is when you disturb a system, when you are disturbing a system, the system will go to another place. So the important thing over here is that this system is not going to return to its original place, and it will keep on deviating, or it will keep on moving away from its original position. This type of system is called as unstable system because it is not stable, right? And this brings us to the next system, that is naturally stable system. This is a flat table sort of thing on which I am keeping a ball. Now this ball again, if not disturbed, will not do anything. It will remain at its position. But what if I apply a little bit of force? This ball is obviously going to move a little bit. Now in this case, it is very important to understand the difference from the stable and the unstable systems. In the stable system, we had the ball coming back to its original position. In the unstable system, we had the ball going away from the original position. But in this system, what happens in the neutrally stable system, the ball will move from its original position. It will obviously not come back to its original position. Okay, so if this ball is going to move to a new position, it will not come back to its original position. The ball will move to a new position and it will remain over there. This is very intuitive. If you have a ball with you, I would like you to do this experiment. Keep it on a table, keep it stable in a state of equilibrium. Just give it a little bit of push. the ball will roll and stay at the other position. The ball will not come back, so it is not a stable system as per our definition. But also the ball will not keep on going on the other direction, so it is not even the unstable system as per our definition. This type of system is called as neutrally stable system. This brings us to the topic for our purpose. This is stability in drones. Now drones, what type of systems are drones? Are they stable, unstable, or neutrally stable? So as you can clearly see on the screen, drones are neutrally stable system. So what does this mean? If the drone is going to be under free fall, what is free fall? If I just leave the drone, if I release the drone, it is going to fall under gravity. It is fall because of gravity. This is called as a free fall. So what happens is when I release the drone, so suppose if I am keeping it at this angle and I release the drone will keep on falling in that same angle. This means that the drone is not going to go back to its original angle, but it will keep on falling, keep on staying on the other stable position that it made. This is the definition of neutrally stable system, right? So the drone is called is comes under the neutrally stable system with respect to its orientation. All right. So this explains us a little bit of little portion of stability that drones are neutrally stable system. But big deal, what does that mean for us? When you are going to make a drone, so we saw a lot of questions where students are wanting to make their own drones. It is very important to understand that drones are not stable systems. If you remember, we saw this point in the previous webinar as well, the previous session, that drones are not stable systems. The quadcopter basically. What happens is because they are unstable or because they are neutrally stable systems, while flying, suppose if the drone is flying right now and there is a wind coming in from one direction, what happens is if because of the wind the drone will tilt. Now you do not want your drone to crash because of this, right? But it is also evident from our concepts till now that the drone is not a stable system. So when this disturbance will hit the drone is not going to come back to its original position, right? Because it is a neutrally stable system. So we need something that will help us make this drone come back to its original position, original orientation, so that the drone becomes a stable system to work with. This is done by using sensors. So a lot of time you will be having these questions that what different sensors are used and why do we actually need a sensor in anything actually. So we need a sensor in drone to make it stable. Very clear. So drones are made stable using sensors. So till now, till this point, we understand that there are three different types of systems based on stability: stable, unstable, and neutrally stable system. And drones come under neutrally stable systems. And because they are not stable, we need sensors so that the drone will become stable and we can work with it. I hope you guys are with me till now. Next, we are going to understand a very important, very crucial topic for us for drones, which is control. How do we exactly control the drone? Now, this is not related with your RC. We are not yet at that level that how do we control using an RC. We first need to understand how the drone basically works. How does it move forward? How does it move backwards? How does it yaws? We have no idea till now, right? So first, let us learn how this happens, how different motions of the drones are controlled. In order to learn that, first thing is we have to understand the controls of an aeroplane. Now we are doing this because aeroplanes are more relatable. A lot of you might have been in an aeroplane, or at least we have seen aeroplanes on TV or in reality, right? So it becomes easier to connect with these motions. Now, as you see on the screen, uh, in order to control an aeroplane, we have three basic controllers: aileron, elevators, and rudders. Each of these is used to control one motion. Ailerons, as you can see, is used to control roll motion. So as you can see on the screen, if you see the blue part of the wings, that is the aileron, and these flaps you must have seen on aeroplane also. These flaps are used to control the roll motion. So if your aeroplane is going left or right, these ailerons are the reason by which that motion is possible. The second thing is elevator. As we can imagine, elevator is going up or down. So just like that, the green part that you see, elevators are used for for making the aeroplane go pitch forward or backwards, which indirectly we are going to control going up or down. If we are going to pitch downwards, the aeroplane might go down, and likewise it will go upwards. So we have aileron and elevator, and the last one is the rudder. The rudder is what you see on in the red color, and using this rudder, we can direct the aeroplane to go your left or your right. So basically, we have these three controllers: ailerons, elevators, and rudders. Next time when you are going in an aeroplane, try to get a window seat near the wings, and you can actually observe these flaps in action whenever your aeroplane is taking off or landing or taking a turn or anything. It is also important that you know that these controls are not used one by one. So for example, if you want to take your drone from this position to this position, you are not going to go forward and then go left. We are going to go directly over here. So that is done by a combination of these controls. For example, if you are riding a bicycle and if you want to go diagonally, you are not going to go straight and then you are not going to go left. You are going to follow the hypotenuse. So you will go forward also by pedaling, and you will tilt your handle also to go in your desired direction. So it is combination of all these things. In the same way, in even in aeroplane, the pilots are going to use the combination of all of these things in order to make a decision of where they want to go, right? Now, if we understand this, I guess next part is the controls of a quadcopter. Let us understand quickly how a quadcopter works. So before looking on the PPT, first try to look at over here. Um, in this drone, we are having four rotors. It is a quadcopter, right? One, two, three, and four. I have used two different colors. I'll tell you why that is in a while. So basically we have these four motors. Okay, how does the drone work? That is what we are trying to understand. How does the motions work? First thing that we need to understand is whenever a motor is going to spin, if this motor is going to spin, then the propeller on the motor is also going to spin. When the propeller spins, it is going to generate thrust. When your drone is going upwards, it is going to generate thrust, and using that thrust we are going to go upwards in any direction actually. So when the motor rotates, we essentially are wanting to generate thrust. It is pretty intuitive that when the motor runs at a higher speed, if the motor is running faster, more thrust will be generated. If the motor is spinning very slowly, less amount of thrust is generated. So before understanding the controls, we are establishing a fact in our minds that more the RPM, more the speed of the motor, more will be thrust. Less the speed of the motor, less will be the thrust. All right. With this in mind, let us understand the four basic controls of a quadcopter. The first one that we see is throttle control. Throttle is essentially going up and coming down. This is This is done by all the four motors together. So if you can see on the screen, the red color means higher speed and the green color means normal speed, which is relatively lower speed. So if I want to go up, what I will do is I will increase the RPM of all the four motors. Higher the RPM, higher will be the thrust and the drone will go up. If you want to land this drone or if you want to go downwards, what you will do is you will reduce the RPM of all of these motors, and by this the drone will come downwards. So we understand the first motion of the drone, that is throttle control. Higher the RPM, increase the RPM of all the four motors, the drone goes up. Decrease the RPM of all the four motors, the drone comes down. Now moving onwards is the pitch control. Now, if you remember, pitch is the going forward and backward. So this is the front of the drone going forward and backward. This motion is pitch. If you remember, last time also we made it pretty clear that pitch is not going front and back. Pitch is simply the tilting. Okay. So in order to understand this pitch, I would like you to remember or I would like you to imagine how a helicopter moves. If you have seen a helicopter, I bet you might have played a game like GTA where you have controlled a helicopter. So in that game, what happens is if the helicopter wants to go forward, the helicopter will tilt and it will go. So if you have not seen, if you can go to YouTube after this and you can see any video you want. So when a helicopter goes in any direction, it is going to tilt in that direction, right? So in the same way, if you are able to imagine this drone, if the drone wants to go forward, first thing is we have to tilt it, right? And this tilting essentially is the pitch motion. So front back movement of the drone is the pitch motion, and because the drone will pitch forward, it is going to go forward. How do we do this? As you can clearly see on the screen, what you need to do is you need to increase and decrease the RPM of different motors. This is just a combination of different motors. So for this drone, rear motors, front motors. Okay, these are the front motors. So if you want to go forward, what you have to do is you have to pitch forward. So if you want to pitch forward, what you have to essentially do is you have to increase the RPM of the rear motors. So what I do is I will increase the RPM of these motors and relatively I will decrease the RPM of these motors. Okay, so what happens is more RPM, more thrust, less RPM, less thrust. So by this what happens is the drone will tilt. Now obviously the drone is not going to just tilt and then we ask the drone ki, okay, now you have to go forward. That is not going to happen. As soon as the drone starts tilting, the drone will start moving in the forward direction. This is how you control the pitch motion. So if you want to go forward, what you have to do is you have to increase the RPM of the rear motors and the drone will go forward. In the same way, if you want to go backwards, if you want to pitch backwards, what you have to do is increase the RPM of the front motors, and by that you will go in the reverse direction, in the backward direction. So I hope this is pretty clear to you that in order to control the pitch direction, you are going to use front two motors and the rear two motors, the combination of these. This takes us to the next motion, which is roll. Naturally, this is also very easy to understand. Roll is the left-right motion, right? So if you want to roll left, what we do is we simply tilt the drone like this. Now in order to tilt the drone like this, what you have to do is you have to increase the RPM of the right motors, two motors. So if you are going to increase the RPM of these two motors, the thrust will increase and the drone will tilt. Relatively, you will decrease the RPM of the left two motors. So as a result, what happens is the drone will tilt in this direction. And as we discussed earlier, the drone will start going in the direction in which it is tilting. So in order to roll left, what we do is increase the RPM of the right two motors, and the drone will go roll left. In the same way, if you want to roll right, you are going to increase the RPM of the left two motors and decrease the RPM of these two of the right two motors, and in this way the drone will roll right. Okay, so I hope you are understanding this as well. So just stepping back a bit, pitch is controlled by the back, two motors at the back and two motors at the front. Pitch back, pitch front means motors at the back and motors at the front, the combination. Okay, roll is the left right motion, so we are going to control the combination of left two motors and right two motors. I guess this makes it easier to remember. Okay, this brings us to the last motion and the most important and interesting motion, which is yaw motion. Okay, now this is not that straightforward. Okay, the yaw motion is this 360-degree motion of the drone. How does this motion occur? How are we going to control this? So if you are able to imagine, when the drone is going to yaw, there can be two basic directions, clockwise and anti-clockwise. I hope you guys understand clockwise, anti-clockwise. The direction in which your clock runs is called as clockwise, and the opposite direction in which your clock runs is called as anti-clockwise or counterclockwise. So in order to determine that direction, you have to look at the drone from the top. So if I tell you that this is clockwise or anti-clockwise, you have to imagine the drone from the top. So if I am looking at the drone from the top, I can easily understand which one is clockwise or anti-clockwise. So a basic exercise for you guys, if you can see the drone like right now, this direction, what will this direction be? This will be clockwise, and this other will be the counterclockwise direction. Okay, I hope this is not going to mirror the camera is not going to mirror the direction, otherwise you will get it totally wrong. But I hope you understand the basic idea. The direction in which a clock runs is going to be the clockwise direction. Now if we understand clockwise and counterclockwise, we can go ahead. So now next time when I say yaw, I will be referring to yaw clockwise and yaw anti-clockwise. Okay, so when I want to yaw in clockwise direction, what I have to do is I have to increase the RPM of the two motors which spin in anti-clockwise direction, the opposite ones. Now comes the point where I explain these two different colors. So in the drone, if you see, I have two white propellers and two black propellers. So this white propeller is basically the counterclockwise propeller. Okay, so this is going to spin in counterclockwise direction, and the black propeller that you see is basically the clockwise propeller, and it will spin in clockwise directions. Okay, so these two diagonally opposite motors and propellers, they are going to spin in counterclockwise direction, and these two motors are the black ones, the black propellers are going to spin in clockwise direction. Okay, with me so far? So we understand that there are two different types of propellers used on the drone, clockwise and counterclockwise, based on the direction in which they spin. If I want to yaw in clockwise direction, okay, this is the clockwise direction. If I want to yaw in clockwise direction, what I will do is I will increase the RPM of counterclockwise propellers. Okay, counterclockwise propellers. Now, okay, before that, even let us consider the other case. If I want to spin, if I want to yaw in the counterclockwise direction, okay, this is the counterclockwise direction. If I want to yaw in the counterclockwise direction, what I will do is I will increase the RPM of the two clockwise propellers. Okay, now first just set this in your brain that we have to spin the opposite direction propeller or the motor. Now understand, let us understand why. This is simply the Newton's third law of motion. Every action has an equal and opposite reaction. What happens is, when the clockwise propellers are running, okay, when two clockwise propellers are running at full speed, okay, and suppose the speed of the counterclockwise propeller is very low. So for this case, clockwise propellers are producing more thrust. More thrust means higher speed. So our mind will basically think that if the clockwise propellers are faster, the drone should also move in clockwise direction. But Newton suggests the other way. Newton said that every action has an equal and opposite reaction, right? So our action over here is clockwise. So equal and opposite reaction would be anti-clockwise or counterclockwise. So for clockwise propellers, what happens is we have counterclockwise motion, and for counterclockwise propellers, what we will have is clockwise motion. So, okay, you can actually check out one of our videos on YouTube where we are actually practically showing you how this occurs. So what we do in that video is we are going to increase the RPM of two clockwise motors, and the in the second video we in the other part of the same video we increase the RPM of the two clockwise motors. In each case, the drone is going to spin in the opposite direction. Okay, I guess uh, it is a video where we are talking about propellers. So you should check that video out, and you will be able to imagine this in a better way. So I guess this makes it like 90-95% clear to you guys. You will be requiring a little bit of video or a practical so that it becomes concrete in your mind. For now, we can be content with the fact that in order to yaw in one of the directions, we need to increase the RPM of the opposite kind of the motor. For clockwise yaw, we need anti-clockwise motors, and for anti-clockwise yaw, we need clockwise motors. This is it. Okay. So basically, we understood the basic controls of the drones today. We understood that in order to move upwards, what we do is we increase the RPM of all the motors. We increase the speed of all the motors. The drones will go up because the thrust is more. And if we decrease the RPM, the drone will come down. If I want to pitch forward, I will increase the RPM of the rear motors. If I want to pitch backwards, I will increase the RPM of the front motors. If I want to roll left, I will increase the RPM of the right motors. If I want to roll right, I will increase the RPM of the left motors. And the last one was yaw. If I want to yaw clockwise, I will increase the RPM of the counterclockwise motors. And if I want to yaw counterclockwise, I will increase the RPM of the clockwise motors. So I think this much would be enough knowledge for today. We will be uploading this webinar as well, this session as well. So if you guys have any doubt, you can ask us. You can refer back to this video and you can watch it again. Now for today's activity, I want you to try out the stability experiment that I showed you in the form of a picture. It is very easy. Just take a bowl, okay, and in that bowl take a marble or something like that. A small ball will also do, and try the experiment. Keep the ball at the bottom of the bowl first, and try to disturb the bowl. So what happens is the marble or the ball will oscillate and it will come back to its original position, stable system. Then invert the bowl and keep the ball at the top. I guess you won't even have to push it. The ball will immediately go down and it will become your unstable system. And obviously you can keep the ball on a flat surface on a table and try to push it a little bit. You will see that it is a neutrally stable system because it will become stable at a new position. All right, so this is one thing that you can try. Of course, you can also check out our video on YouTube to understand about these four motions in a better way. And the third and the another activity that I want you guys to answer us is Is a standing man a mechanically stable system? Okay, a standing man. Now, a few restrictions on that man is the man has both his legs and both his hands tied. Okay, so the man cannot move freely. Okay, and if what happens if I simply push that guy? If is that man a mechanically stable system or an unstable system? I am not going to answer it right away. I want you guys to try it out and let us know what you think about it. And I will answer it in the next session. This brings us to the end of the session for today. You guys can obviously follow us on Facebook, Insta, YouTube, Twitter, and LinkedIn. There are lots of cool videos on YouTube for you guys who are drone enthusiasts. You can learn a lot more about drones over there. And I guess that's it. We can take some questions. We have some time.
So we'll take. All right. So we'll take some questions from the audience. We've had some very interesting set of questions, very similar to the ones we had last time. Some of them we have answered in the published section, but why don't I also address some of them? So one interesting question which I believe came last time also, but I'll still kind of put it out, was can we attach solar panels with any drone? Can we have a drone that's powered entirely by solar energy?
So this is a very interesting question which we have received a lot of times, and it is a very valid question because solar energy we all know that is a renewable source and it will be very good rather than charging this battery for using your electricity at home because it is generally a non-renewable source of energy. So the problem with solar energy is that it is a very low power per square meter. If you understand the quantity of energy, the amount of energy that you get from solar power, solar cell is very less, and drone consumes a lot of energy. So if you have seen a solar farm, they have acres and acres of land with big solar panels, and that way they generate a very good amount of energy. So it also is a very slow kind of energy. If you understand, I'm trying to frame it for in a very simple terms. You require a lot of time to gather good amount of energy that can be used. So yes, the idea is very good that you can put a solar panel and then you fly it in under sun. But what happens is it does not get enough amount of energy that the drone will be able to fly. Of course, in future, who knows if someone is able to harvest solar energy in another way and if they change the way, it might work out. But for now, it is very challenging.
Got it. There's another question that has come up, which is, do the motors always rotate in one direction, or based on our requirements, can we change them?
Okay, so that again is a very good question. So when I say that this is a clockwise motor and this is a counterclockwise motor, essentially it depends on the type of current that you give. The motors are generally having a direction, a particular direction in which they rotate, uh, which the company specifies. But obviously, you can change the positives and negatives if you understand. So every motor has a positive and a negative wire connection, and the way you give the power to that motor, the direction is going to be decided. So if you interchange the connection, the direction will also change. So that one such feature actually is available in Pluto X. This is Pluto 1.2. I will not be able to show you that feature, But if you see, there are 4 motor ports in this, and these are unidirectional, so you cannot change these directions. But in Pluto X that we have, there are 8 motors, 8 motor drivers, and for the 4 extra that we have in that is they are bi-directional. So you can actually program whatever direction you want. So you can ask the motor to go in clockwise or counterclockwise based on your application. So yes, the directions of motors can be changed if required.
Got it. Um, one interesting question I believe that relates to the session we had last time was you mentioned that the drones, the assault drones, the ones that launch missiles, are generally imported into the country. So, which are the countries that actually manufacture these type of drones?
I believe one such country obviously is America. Then Israel is a very good country in defense. They also manufacture this. To some extent, I guess India also does. So basically, all the, I guess, uh, good countries in terms of defense development would be manufacturing. India does manufacture, I believe, and we have a good defense system in that manner. But US, Israel are also two pioneers in this matter, in this area.
So primarily US and Israel are the largest like
Yes,
suppliers of such drones to the world.
right.
Awesome. Cool. Um, I'm still looking at a few interesting questions. We've tried to answer them as aggressively as we could. So we have a good chunk of these that are in the published section. We've answered almost 50 questions there. Um, Another question here is: Can do micro drones carry more weight than the nano drones?
Yes, the micro category itself is consisting of drones heavier than nano drones. So if you see this drone, this is a nano drone. It weighs around 50 grams. So, but obviously the drone which will be bigger, which will be heavier, which will be having better, more powerful battery, will be able to pick up more load than compared to this. So based on your requirement, you can decide the size, the capacity of the drone that you want to build.
Correct. Another question that has come up is: Are the drones that are used for defense, are these manually controlled or are these primarily pre-programmed?
Could be either of them. They can be they can be programmed to uh, go follow a certain path and finish the job, whatever it may be, maybe attacking or maybe surveillance. It can also be controlled by a remote mission control sort of a place where people are handling the drone and they are asking the drone to do whatever they want. If they want to it to go to a specific place and do its job.
Correct. One interesting question that has come up is so this looks like that it's come from an aspiring businessman. His question is, why are the drones that we make at home generally expensive as compared to the ones we buy from the market? Would you like to take a shot at that?
So uh, I guess it is a very interesting actually entrepreneurial question. So what happens is when you make anything, not just drones, but whenever you are trying to manufacture anything, the prototype is very expensive. So even if when we make this drone, if I am going to make one of this drone, each and every component is going to be very expensive for me. But as I start making this on a very big scale, on a very large scale, when I start making them in hundreds and thousands and 10,000s and lakhs, this cost starts reducing considerably. So if I'm going to make just this one drone, it will be very expensive for me. But if I'm going to make a lot of these drones, the cost of all the parts reduces, and hence I will be able to sell the drone also in a at a reduced cost than what I will be doing at when I make just one drone. I hope this answers this question.
I think it does. I think it does. There's one question I thought. I think I saw that a few more times, like a few, like multiple times in our list of questions, and it's related to today's lecture. So can you just help us understand the concept of equilibrium once again a little better?
Okay, equilibrium. So um, let me think of an example. Um, so suppose you are in your classroom and you want to move a desk. Okay, so desks generally are movable by just one person, but assume that this is a little bit heavier desks and you want to move these desk. Okay, this desk. Now what you do is you start pushing it from one side. Okay, and you ask your friend for help. So if we assume that this is your desk, all right, I am trying to push it from this end. So I imagine that when I push, the desk will move to the other side. But what happens is it is very heavy and I am not able to provide enough force. So what I tell is I ask my friend to come in to help me. Now my friend is very smart, okay? When I am pushing it from this side, my friend who wants to help me comes and starts pushing from the other side. Okay. So I am trying to push from one end, my friend is trying to push from the other end. What do you think will happen? Will the desk go in the direction which I want? Obviously not, because what happens is both our forces are going to cancel out each other. Okay. So what I tell my friend is that you should instead actually come on my side and help me push the desk. So both of us are going to be over here, and now we are going to push the desk a little bit easily. So what this explains is on this desk there were a lot of forces acting. Okay, the weight of the desk, okay, the friction when I'm pushing it, a lot of these forces come into play. So when all these forces are equal and opposite, for example, me and my friend, when we were applying equal amount of force, the desk was not moving anywhere. But as soon as we pushed it from one end only, the force was unbalanced because there was nobody from applying force from here. So this unbalanced force makes the desk easily move easily. So I hope this clears up the concept. When equal forces are acting on a body, they tend to cancel each other out. Obviously, if they are in opposite directions, like in our case. But if one of the force is more than the opposite force, the object, the body is going to move in that direction, and it will not be in equilibrium. So if I just keep the box in my hand, and if there is no external force acting on it, right now I am providing equal force as compared to the weight of the box, and hence the the box is at equilibrium. I hope this answers the query.
I think it does. In fact, I'm going to kind of since we got a few more of these questions, I'm going to ask this like a corollary of this question, wherein if you have an object that is going at a constant speed in some direction, but it
Mhm.
is not increasing speed, it's not decreasing its speed, or and it's not changing the direction, would you call such an object in equilibrium?
It is actually an interesting question. It can be considered as a type of equilibrium. So when we were talking about equilibrium in this topic, it was basically when an object is at rest. But if an object is in a uniform motion, there will be no acceleration on it, as Newton's law suggests, and hence the body will stay in that particular motion only, and hence that also will be an equilibrium.
Got it. Got it. Awesome. Um, I'm still looking at some of the questions which we have not answered, or some of the questions that we have answered uh, just individually. A lot of questions have come around. Um, a lot of questions have come around drone deliveries, right? Can we have a micro drone? Or can we? What sort of category of drones will we require for a drone delivery? Uh, can you do it with a nano drone, or what other category will you require to do it with? You can, if you want, you can pass it on to me also at any point of time. Yeah.
Okay, I guess micro, it will depend on the payload capacity. With nano, it will be very difficult, but micro would be able to do it for a very lighter things, but you might require even the higher categories if needed.
Got it. Got it. So I think for it, depending on the payload, if you are looking at very light payload, something like a micro drone might work. And if you're looking at some really heavier objects like in a few kilograms, then maybe a small category drone could work for you. If you're looking for tens of kilograms, then maybe you would require, like, a small drone won't work, but a medium sized drone is what you will require. So yeah. um, I'm also looking at a few more questions. I think a good chunk of questions that were there have been answered. We had one question that came up a good number of times, which was, so a lot of people have submitted their assignments through the email. Have we received it? And like, yeah. So if you want, maybe Shachi Mankar could help us answer that question.
Yes, we have received a lot of answers, and the school with maximum submission will be given a small gift. We will know the school's name at the end of the 6 sessions.
Awesome, awesome. So, guys, all the assignments that you're submitting, all the answers, all the questions you are answering and sending us through mail, that will actually help your school earn a small gift from us. So, dig deep into it and reach out to us. Also, reach out to us on droneaviation.com/forum in case you have more questions. We will be more than happy to answer any of these questions that come our way. Right? Um, I think that is almost it. We are almost at the end of our session. Thank you, Keval sir. It was a superb session. I personally had a good time. I think I've heard this lecture from you many times, but every time you deliver it, you bring in a new flavor, a new thing to it. So I enjoy this every time. And the good thing is that we are going to put it up on YouTube. So any of you who want to undergo a formal course and just want to get your basics brushed up, check out the YouTube channel. We have created a specific playlist for all of the sessions that we are conducting on for all these 6 sessions. So we'll share the links with you and check those out. If you have any questions, say, ask us on droneaviation.com/forum. And with that, I wish you guys a super happy weekend. Have fun, and we will catch you next week. Cheers. Bye.